students, let us continue with uniform and non-uniform linear motion. Amar, Akbar and Anthony are traveling in different cars with different velocities. The distances covered by them during different time intervals are given in the following table. Time in the clock 5, 5:30, 6, 6:30, 7, 7:30 and 8 o'clock. Distance covered by Amar in kilometers 0, 20, 40, 60, 80, 100, 120. Distance covered by Akbar in kilometers 0, 18, 36, 42, 70, 95, 120. Distance covered by Anthony in kilometers 0, 14, 28, 42, 56, 70, 84. Use your brain power. What is the time interval between the notings of distances made by Amar, Akbar and Anthony? So the time interval given is 30 minutes. Who has covered equal distances in equal time intervals? Amar and Anthony have covered equal distances in equal time intervals. Are all the distances covered by Akbar in fixed time intervals the same? No. Considering the distances covered by Amar, Akbar and Anthony in fixed time intervals, what can you say about their speeds? Amar and Anthony are traveling with uniform speed and Akbar with non-uniform speed. If an object covers equal distances in equal time intervals, it is said to be moving with uniform speed. So please mark this definition. If an object covers unequal distances in equal time intervals, it is said to be moving with non-uniform speed. So please mark this definition. For example, the motion of a vehicle being driven through heavy traffic. Now, let us see in the slide the examples of uniform and non-uniform motion. Car A travels equal distances in equal intervals of time, so it is in uniform motion. Example, the movement of the hands of the clock. They move equal distances in equal intervals of time. Car B travels unequal distances in equal intervals of time, so it is said to be in non-uniform motion. Example, the athlete running in a race. Now, let us move on to a new concept called as acceleration. Take a 1 millimeter long plastic tube and cut it lengthwise into two halves. Take one of the channel shaped pieces, place one of its ends on the ground and hold the other at some height from the ground as shown in the figure 1.4. Take a small ball and release it from the upper end of the channel. Observe the velocity of the ball as it rolls down along the channel. Is the velocity same at all points? No, it's not the same. Observe how the velocity changes as it moves from top through the middle and to the bottom. Now let us go on to the next page, page number 5. You must have all played on a slide in a park. You know that while sliding down, the velocity is less at the top. It increases in the middle and becomes zero towards the end. The rate of change of velocity is called acceleration. So mark this definition of acceleration. Now, acceleration is equal to change in velocity of time. If the initial velocity is u and in time t it changes to the final velocity v, acceleration is equal to a final velocity minus initial velocity upon time. Therefore, a is equal to v minus u upon t. If the velocity of an object changes during a certain time period, then it is said to have accelerated motion. An object in motion can have two types of acceleration. If the velocity changes by equal amounts in equal time intervals, the object is said to have uniform acceleration. Second, the velocity changes by unequal amounts in equal time intervals. The object is said to have non-uniform acceleration. Use your brain power. 1. When an object is at rest at the beginning of its motion, what is its initial velocity? So it is 0. Second, when an object comes to rest at the end of its motion, what is its final velocity? Again it is 0. Now let us go to the concept of positive, negative and zero acceleration. An object can have positive or negative acceleration. When the velocity of an object increases, the acceleration is positive. In this case, the acceleration is in the direction of velocity. When the velocity of an object decreases with time, it has negative acceleration. Negative acceleration is also called deceleration. So you can mark these two definitions. Its direction is opposite to the direction of velocity. If the velocity of an object does not change with time, it has zero acceleration. So I hope you have understood positive, negative and zero acceleration. Now let us look at the figure given here. Look at the graph here. It is going up, then a straight line and then it is coming down. So here between the time intervals of 0 to 2 seconds, the velocity of the particle is increasing with respect to time. Hence the body is experiencing a positive acceleration as the slope of the Vt, that is velocity time curve, in this time interval is positive. Between the time intervals of 2 to 3 seconds, the velocity of the object is constant with respect to time. Hence, the body is experiencing zero acceleration as the slope of the Vt curve in this time interval is 0. Now, between the time intervals 3 to 5 seconds, the velocity of the body is decreasing with respect to time. Hence, the body experiences negative value of the rate of change of velocity as the slope of the Vt curve in this time interval is negative. It has come down. Now, let us study distance time graph for uniform motion. The following table shows the distances covered by a car in fixed time intervals. Draw a graph of distances against time, taking time along x-axis and distance along y-axis in the figure. Time in seconds 0, 10, 20, 30 seconds, 40, 50, 60, 70. Distance 0, 15, 30, 45, 60, 75, 90, 105. Now on the x-axis you can see time in seconds 10 to 80 and y-axis 20 to 140. Scale taken on x-axis is 1 centimeter is 10 seconds and y-axis 1 centimeter is 20 meters. So the points are plotted. You know how to plot the graph. So 0, 0 here at the origin. Then first is 10 and 15 point. Second is 20 and 30. Third is 30 and 45. Fourth is 40 and 60. Fifth is 50 and 75. Sixth is 60 and 90. And last one is 70 and 105. So you can see it is a straight line. So now let us go to the next page. So an object in uniform motion covers equal distances in equal intervals of time. Thus, the graph between distance and time is a straight line. Use your brain power. In the distance time graph above, what does the slope of the straight line indicate? The slope indicates uniform motion. Now, let us go to the distance time graph for non-uniform motion. The following table shows the distances covered by a bus in equal time intervals. Draw a graph of the distance against time, taking the time along the x-axis and distance along the y-axis in the figure 1.6. Does the graph show direct proportionality between the distance and time? So here the time is given to you and the distance is also given to you. So we have taken the scale on x-axis as 1 centimeters is equal to 5 seconds and y-axis 1 centimeter is equal to 10 meters. Now here, so we have plotted the graph and you can see it is not a straight line. So here the distance changes non-uniformly with time. Thus, the bus is having non-uniform motion. Use your brain power. What difference do you see in the distance time graphs for uniform and non-uniform motion? So here for uniform motion it is a straight line with constant slope, and for non-uniform motion it is slightly curved line with the slope not constant. Now let us go to velocity time graph for uniform velocity. Now a train is moving with a uniform velocity of 60 kilometers per hour for 5 hours. The velocity time graph for this uniform motion is shown in figure 1.7. So you can see in the figure there. Now, first question, with the help of the graph, how will you determine the distance between covered by the train between 2 hours and 4 hours? So here we can say that distance is equal to velocity into time. So that is equal to 60 into 2, that is equal to 120 kilometers is the distance covered by the train between 2 hours and 4 hours. Now second question, is there a relation between the distance covered by the train between 2 hours and 4 hours and the area of a particular quadrangle in the graph? What is the acceleration of the train? So let's answer the first question. Let AC and BD represent the velocity of the train. Area of quadrangle ABCD is equal to AC into CD is equal to AC into CD, that is length into breadth. So that is equal to 60 kilometers per hour, and in the bracket 4 hours minus 2 hours. So that is equal to 60 into 2, that is equal to 120 kilometers. So the area of this quadrangle covers the distance covered by the train in 2 hours. Now, second question is, what is the acceleration of the train? So the acceleration of the train is 0 here. How? Because acceleration is equal to final velocity minus initial velocity upon time. So 60 minus 60 upon 2, that is equal to 0 meters per second. Now let us go to the velocity time graph for uniform acceleration. The changes in the velocity of a car in specific time intervals are given in the following table. So here time in seconds is given to be 0, 5, 10, 15, 20, 25, 30, 35. Velocity meters per second 0, 8, 16, 24, 32, 40, 48 and 56. So on the graph you can see time is plotted on the x-axis and y-axis the velocity is plotted. Scale given on x-axis is 1 centimeter equal to 5 seconds. Y-axis 1 centimeter is equal to 8 meters per second. Now here the velocity time graph. The velocity changes by equal amounts in equal time intervals. Thus, this is uniformly accelerated motion. As you can see, it is a straight line. How much does the velocity change every 5 minutes? So we know that 60 seconds is into 8 meters, that is 480 meters is the final velocity, that is v. So acceleration is equal to v minus u upon t, that is 480 minus 0 upon 5 minutes, that is equal to 480 upon 300 seconds, that comes to 1.6 meters per second. Second, for all uniformly accelerated motions, the velocity time graph is a straight line. Third, for non-uniformly accelerated motions, the velocity time graph may have any shape depending on how the acceleration changes with time. Now, from the graph in the figure 1.8, we can determine the distance covered by the car between the 10th and the 20th seconds, as we did in the case of the train in the previous example. The difference is that the velocity of the car is not constant, unlike that of the train, but is continuously changing because of uniform acceleration. In such a case, we have to use the average velocity of the car in the given time interval to determine the distance covered in that interval. From the graph, the average velocity of the car is 32 plus 16 upon 2, that is equal to 24 meters per second. Multiplying this by the time interval, that is 10 seconds, gives us the distance covered by the car. Distance covered is equal to 24 meters per second into 10 seconds, that is equal to 240 meters. Check that similar to the example of the train, the distance covered is given by the area of the quadrangle A, B, C, D. Now, area of quadrangle A, B, C, D is equal to area of quadrangle A, E, C, D as given in the figure plus area of triangle A, B, E. You can see it in the graph. So we know that area of quadrangle AECD is equal to length into breadth, that is 10 into 16 is 160, plus area of triangle ABE is equal to half into length into breadth is equal to 160. So adding both the areas, we get the area of the quadrilateral ABCD as 240 square meters. So I hope students you have understood these graphs well.